Symmetry. We're going to be talking about the symmetry of some graphs and their equations. Knowing symmetry of a particular equation, if you were trying to solve a particular problem or graph that equation, if you happen to know the symmetry of it, it really helps you out quite a bit. So symmetry is extremely important. Let's look at some graphs that have symmetry. Okay. This first graph over here on the left, it has it's symmetric about the y-axis. And the way you can see that is, pretend the y-axis is a mirror, and so what you get over here in quadrant 1 and quadrant 2 is just a mirror image of each other. So this is symmetric about the y-axis. Alright, let's look at this graph over here on the right of a circle. I've tried to center the origin here. This has got all kinds of symmetry going on in this graph. It is symmetric about the y-axis. If you can think of the y-axis as like being a mirror, and so what you see over here in quadrants 1 and 4 is the exact same graph, except it's being flipped about the y-axis is over in 2 and 3. This is also symmetric about the origin. I guess I should note this. If you take a graph and you like rotate it 180 degrees and you get the same graph back, it's usually symmetric about the origin. Okay, let's look at these graphs here. So this graph is symmetric about the x-axis. As you can see, we get a mirror image, right? So this graph is flipped across the x-axis and you get a mirror image of it. So this is symmetric about the x-axis. Now this graph here, you're going to have to rotate it. You get the same graph back. Therefore, this graph is symmetric about the origin. You can see that it's not symmetric about the y-axis or the x-axis. Alright, let's look at how to test for this symmetry algebraically. Okay, so I'm giving this equation here, y is equal to x squared. Now we're going to be testing for y symmetry, or symmetric about the y-axis. And what you do is you're going to replace your x, replace the x with a negative x. And we do that here, as you can see, negative x squared, and you end up getting x squared back, because if you square negative it's positive, and therefore we end up getting back the same equation that we started with after replacing x with a negative x. This means that it is symmetric about the y-axis. And if you remember that this graph was that very first graph, it was a parabola. So let's say that we were testing to see if this graph was symmetric about the y-axis. Well, we would throw a negative in, negative x in here, simplify it, and we don't get back the same equation as we did in the beginning. So we know that it's not symmetric about the x-axis. And if we threw in replaced y with a negative y, we would be testing to see if it's symmetric about the x-axis. Well, you'd obviously not get back the same equation. So we know that this is not symmetric about the x-axis. But if we threw in, replaced y with a negative y and replaced x with a negative x, and then simplified it down, as you can see here, we do get back the same equation. And what this means is, if this is symmetric about the origin, this is symmetric about the origin. Okay, in this particular one here, we're testing to see if this equation is symmetric about the x-axis, because we are throwing a negative y in, replacing this y with a negative y, and we do get back the same equation. So this means that this is symmetric about the x-axis. So those are our possibilities of finding symmetry. Let's look at this one other. This is the equation to a circle, and its radius is the square root of 5. So remember what I said about the circle is it had x-axis symmetry and y-axis symmetry, and it also has it's symmetric about the origin. And when we replace this x and this y with a negative x and a negative y, and as you can see, we get back the same equation. So it's obviously symmetric about the origin. And if you were just testing for symmetry about the x-axis, you would throw just a negative x in here, leave the y alone, and of course we would end up getting back the same equation, which means that that would be symmetric about the y-axis. And then vice versa, if we threw a negative y in but left the x alone, it would be symmetric about the x-axis also. So there's all kinds of symmetry going on here in this circle.